Hi, we're working with a radical equation now. This is problem number 33, and we're going to solve this equation. Better put my glasses on if I'm going to see. There we go. So the problem is number 33, which is the square root of x plus 49 plus 7 equals x. There are steps you have to follow. The first one is to always isolate the radical. In this problem, you have only one radical. So subtract the external 7 from both sides. Now the square root of x plus 49 equals x minus 7. The second step is to square both sides of the equation to get the square root off of x plus 49. So here's the equation. Square root of x plus 49 equals x minus 7. And we will now square both sides of this equation. On the left, the squaring just takes off the radical. But on the right side, this is all part of step 3, which is solving. Now you're going to solve the equation. When you square the right-hand side, you've got to remember to FOIL. This is a binomial. You're going to have a binomial times a binomial. So x plus 49 is going to equal x squared minus 7x minus 7x plus negative 7 times negative 7 is 49. So this will give us, let's combine our like terms, x plus 49 equals x squared minus 14x plus 49. Now we use the zero principle, which is to drag everything in the quadratic equation over to one side, set it equal to 0. Because you notice we have all three terms here. We have the A term, we have the B term, we have the C term, otherwise known as the quadratic term, the linear term, and the constant term. This will give us a 0 on the left-hand side, which is using the zero principle, having the 0 on one side. We'll be left with x squared minus 15x because the 49's 0 out. Now the easiest way to handle this is to factor. When you've got a quadratic and a linear term, factor it. Factor by the common factor. Pull out an x. You'll have x times x minus 15. Set each factor equal to 0 and solve. X is already equal to 0, but here x is going to equal 15. So it looks like you have two answers, two solutions, 0 and 15, right? Not necessarily, because this is a radical equation. You don't know if either of those answers works in the original radical equation. You have to check each solution, or each possible solution, because all they are right now is possible solutions. 0, and 15. If you're wondering what that rattling is, that's my dog Ayla chewing on a bag. 0 plus 49, I'm testing x equals 0. 0 plus 49 plus 7 equals 0. Is this a true statement? I put 0 in for the x's. That will give me the square root of 49 plus 7 equals 0. 7 plus 7 equals 0. No, I don't think so. 14 equals 0 is false. So that means that 0 is not a solution. Now that doesn't mean that 15 automatically is. We need to check 15 as well. I've solved problems where neither answer works. All right, we'll put 15 in for both the x's. The square root of 15 plus 49, plus 7 equals 15. So this will be the square root of 64 plus 7 equals 15. 8 plus 7, does that equal 15? You bet. So 15 equals 15. That's a true statement. And what that means is that 15 is a solution. It's our only solution to this problem. There's Ayla, the black lab. All right, so let's put 15 in the answer box and check it. It works. Hooray for us. Hi there. This is homework problem number 34. We're going to graph what's called a linear inequality in two variables, x and y. That means you're going to graph and shade. You can use a TI graphing calculator to help you. Watch carefully what I do. I'm going to use my left arrow key to move all the way to the left, and you're going to see a slanted line kind of wagging. Hit enter and the line changes shapes. We want the upper triangle, which means greater than. Now, graph y1. Is that cool? The area above y equals 2x is what we want. So let's get some points by saying second graph. Get a couple of points there. Now come over here. And we hit the magnifying glass to make this larger, and now I'm moving it into place so I can work with it. Okay, choose the line tool and go to the first point you've chosen. Mine is 0, 0. So I click on 0, 0. Then I go to the second point I've chosen, which is, oops, now this is hard. This is very tricky. You got to be really careful. I want the point 2, 4. Click. Now I've got it. The line turns yellow. And now look, I choose whether I want the line to be solid or dashed. Strictly greater than takes a dashed line, as does strictly less than. Now I'm dragging the paint can over to the upper side of the line, which is what we saw was shaded in the graphing calculator, and I check my answer, and voila, we got it right. Now I'm clearing the calculator And I'm going to the next problem, which is number 35. Here we're going to graph two linear inequalities in two variables, and then we're going to find the vertex. You'll see what that is. You can already do it. You already know how. All right, first I'm going to graph the line in the calculator, y equals x, and then for y2, y equals 2 minus x. So y equals x goes in y1. Now I'm going to go over to the wiggling line, and I need less than. True, it is less than or equal to, but less than is good enough for what I want to do. That's a lower triangle. Lower triangles mean less than. Now in y2, well, first, I'm going to come down to y2, and I'll click 2 minus x, and then I'll go over to the left, and I'll hit enter until I get an upper arrow, because that means greater than, which is what I have in the y2 problem. So there I go. I'm ready to graph. There's y1. There's y2. The darker area, which is the overlap of the two shadings, that's going to be the answer to our problem when we graph it. So now look at this neat trick that I'm about to do. I go back to y equals. I come down to y2 and over to the equal sign, and I hit enter. What that does is that takes the highlighting away from the equal sign on y2 so that all I'll see is y1. Now, when I say second graph, I can find points for graphing y1. So I'm going to expand the graph, get a medium, I'm going to choose the line tool, and I'm going to find my first point, which is 0, 0. And then I'm going to choose 1, 1. And the line is going to be solid because we've got less than or equal to. Now I'm not shading yet. I'm going to go down to y2. No, I'm going to go to y1 and hit enter on the equal sign in y1 to turn it off. Now I'm hitting enter on the equal sign in y2 to turn it on. I'm going to graph it. There's y2. Now I'm going to get points. Let's see, 0, 2, and 1, 1. No, let's see which points I choose. 0, 2, and 1, 1. Or maybe I chose 2, 0. Looks like I chose 2, 0. Doesn't matter. Now I'm going to turn on the on y1 by clicking on the equal sign. There I go. I want to shade that area by dragging the paint bucket over to it. There's my answer. I'm going to check the answer. Well done. Now to find the coordinates of the vertex, which is the point of intersection of these two lines. It's the solution of the system in this case. It's a little more complicated later on, but right now it's the solution of the system. We need paper. It's where these two lines cross. So we're going to have to solve the system by either elimination or substitution. So this is problem number 35. I've got two lines, y equals x and y equals 2 minus x. The equal sign is used with just the line. This is a system of linear equations. Well, y equals y. So I'll take what y equals in the first equation, x, and put it in for y in the second equation. So I'll have x equals 2 minus x. I'll solve for x by adding x to both sides. That will give me 2x equals 2. Divide by 2, divide by 2, and I'll have x equals 1. Now we're not done. Now I have to find y. Remember, y equals x. That's line number 1. So I'll substitute x equals 1 into the x. And the solution to the system is the point 1, 1. It's where the two lines cross, which also is the vertex to our system. It's the vertex to the system of inequalities. So let's put that point in here. You must use parentheses. Always use parentheses for a point. Check the answer. Well done. We're correct.